Database is to perform automated processing of a sequence of signal analysis specified by user for database generation / recall / statistical analysis and report generation. Its M2 menu includes 3 buttons for 3 major steps of database analysis, which are define database, generate database, and recall database. Define database is to define multiple pages of signal analysis on a typical representative test data file. Generate database is to process new input data files by performing the signal analysis as defined in the database and save the analysis results into an organized database. Recall database is to recall database information and generate database statistics which can be overlay on future tests for statistical comparison. Let's start with Define DB by turning on its M2 button. A DB setup menu will be shown. In the DB name, click on this down arrow. To create a new DB, select an empty DB name in the pull-down list such as this DB22. A DB name text box will be shown. Enter the desired name for the new DB, such as Demo Database Auto Data Package. An empty DB menu will be shown for this new DB22. First select a DB output folder, for saving all output DB files. Then open a typical representative test data file as the setup test, such as demo db1.dat. All future test data to be processed by this DB should have the same sampling frequency and data channels as the setup test. To define signal analysis for this DB, simply perform the regular analysis setup from the various menu buttons such as the M1 and M2 menu, left and right menu. When done, click Save DB and the current page's setup will be saved into the DB menu. Repeat step 4 and 5 for next page until all pages are completed. Let's use an example to demonstrate these procedure for Define database. The requirement is to set up a database which can automatically generate a post-test data analysis package with the following signal analysis. These include page 1 for RPM and power level profile as the reference window. Page 2 is max-min waveform reduction from 2 XL channels, and the same 2 channels will be used for page 3 to 11. Page 3 is RMS reduction over the full frequency band. Page 4 is composite RMS tracking within the frequency band of 25 to 500 Hz. Page 5 is histogram within the same frequency band of 25 to 500 Hz. Page 6 is peak RMS tracking at sync frequency 1N along with its scatter diagram with respect to RPM. Page 7 is relative phase tracking at sync frequency also with its scatter diagram with respect to RPM. For page 6 and 7, it will generate 2 plots. The first one is parent plot from sync RMS and phase tracking, and the second one is populated plot from the right menu action of scatter diagram. And these 4 output plots represent the sync vector and Bode diagram. Page 8 is peak RMS tracking at 4N. Page 9 is for 4-second averaged PSD at multiple time segments of interest, which are defined by the PST. This page will produce multiple plot, one at each time segments. Page 10 is 3D PSD spectrogram. Next, let's see how to define a database that can meet this requirement. Starting page 1, which is to generate RPM and power level profile in reference window. Since power level information is from performance data, therefore the input needs to be set to input to mode as single DD and PD file. Next, turn on reference window button. Select the first option to show its menu. First set up the speed or RPM profile based on time domain tracking of the speed channel. Also turn on the performance data option to import power level profile from performance database. Then click Save DB. The setup for page 1 is now saved into this DB table. The next page is max-min waveform reduction. Turn on Basic in M1. Select max-min in M2. In Channel menu, select the 2XL channel from channel 5 and 6. These 2XL channels will also be used for all other pages. In Processing Parameter menu, enter 512 as the sliding window size for max-min reduction. Notice that, for analysis time selection, instead of enter a fixed start time and end time, we need to select this Auto Full Time button as a variable time. This way, when process future test data using this database, the start and end time of the new data file will automatically be used as the analysis time frame. Click on this Append and Save DB button. The setup for page 2 is now saved into this DB table. Next, page 3 is for RMS reduction. Turn on Basic in M1. RMS in M2. Select the same 2XL channel. And Auto Full Time again. Click Append and Save. The setup for page 3 is now saved into this DB table. The next page is for composite RMS tracking from 25 to 500 Hz band. Turn on Tracking in M1. Select CRMS or Composite RMS in M2. Select Fixed Band from 25 to 500 Hz. Select the same 2XL channel. Click Append and Save. Page 4 is now saved into DB table. Page 5 is to generate histogram of the bandpass filtered signal from 25 to 500 Hz. In M1 select Basic. In M2 turn on Filter. Select passband frequency from 25 to 500 Hz. Then turn on histogram. Click Append and Save. Page 5 is now saved into DB. Next, set up page 6 for peak RMS tracking at 1 sync frequency 1N as well as its scatter diagram with respect to RPM. Turn on Tracking in M1. Select Peak RMS in M2. Select 1N in M3. Also in right menu, turn on Scatter diagram. In its menu, first select 1 SD reference. From page 1 reference window, select Parent plot. And select Subplot 1 which is RPM profile. Then select 2D scatter diagram. For all subplots of the current page. Click Append and Save. Page 6 is now saved into DB. Next, page 7 is phase tracking at 1N along with its scatter diagram. M1 is still tracking, but switch to phase tracking in M2. 1N in M3. Also turn on scatter diagram in right menu. And set up its menu as last page. Click Append and Save to save page 7 into DB. Page 8 is peak RMS tracking at 4N. Switch M2 back to peak RMS tracking. and select 4N in M3. Click Append to save page 8 into DB. Page 9 is for 4-second averaged PSD at multiple time segments of interest, as defined by PST. Turn on Basic in M1. PSD in M2. Then turn on 3 left menu buttons. Match, Peak List, and PST. The PST menu will show the multiple time segments for generating the averaged PSD. User can either enter the PST time segment manually or use auto-gen mode based on gating of the RPM profile. Select the same to Excel channel. Click Append to save page 10 into DB. The last page 10 for 3D PSD spectrogram. Turn on 3D window in M1. 3D PSD Gen in M2. Select the same to Excel channel. And select Auto Full Time again. Click Append and Save to save page 10 into DB menu. This complete defining the DB for Auto Data Package. As demonstrated above, define DB is very similar to regular analysis. The only difference is that after setup in M1, M2, M left and M right menu. Instead of clicking on the Start button for regular analysis, define DB needs to click Save DB button, or Append and Save DB button to save the current page setup into DB. More detailed setup information for each page is also shown in the DB menu, such as Test ID, which is input dynamic data file name, M1 menu setting, M2 menu, M3 menu, such as the tracking component at 1N and 4N in page 6, 7, and 8. Selected channels. Analysis time frame. Frequency info, such as frequency band for page 4 and 5. Also left menu setting, such as the match, peak list, and PST in page 9. Right menu setting, such as scatter diagram in page 6 and 7. If need to perform the analysis of a particular page in play mode rather than start mode, then simply double-click on the cell under this play column to turn on the play mode.